Yes, we are missing the audio, so we'll patch that in later. All right, our guest today, after 4 years of absence, is Dr. Simon Monk. And Simon, by the way, the USA numbers, if you want to call and talk to Simon or contribute to the discussion, they were up there for a second. And now we're going to move over to live and show our honored guest, our honorable guest, I don't know, whatever it is. Simon, hello and welcome back.
Hi, nice to see you again. How are you?
It's great to see you. I'm going to show a still of Michael Graves, who apparently is having a few problems. And he's back. Hello, Michael.
Hello.
There you go. Mr. James Bodie on his left.
Good evening, chaps.
And of course, the ineffable Andy Smith on the extreme left.
Effable. Hello.
Effable or ineffable? Yeah, I don't even know what that means, but it sounds weird.
Yeah.
Anyway, I thought we would start, Simon, with when you were here last time. We always ask people what their background is, but that's pretty well known, and I think you gave yours last time, and your bio is on the site vuc.me. Along with, I would like to add many of your recent books, links to them. They're Amazon links. They should go to. They work in Canada, the United States, and the UK for Amazon. So go ahead and click on those.
Well, thank you very much for that.
And my first question to you would be what your gateway technology was. I know that I saw a magazine article about building a TV camera with lamps, valves, I guess you call them, and chassis punch and aluminum chassis and buying all the parts. That got me going, but that's a much older level of technology. What was your first technology that spoke to you and said, you got to try to build one of these?
Okay. Well, it was a metal detector, I think, my first electronic project. So I used to go down to the local library and get out Practical Wireless. Do you remember Practical Wireless? Great magazine. Yeah, they're getting a thumbs up over there. It's and I used to go and get these out, and then you'd have a design that used strip board, usually not even 0.1 inch strip board. So you're talking about, was it 177 inch, something like that? Anyway, quite wide strip board, and you get a strip board layout, and you'd go down to one of the 3 local electronics stores that were in my hometown, Wolverhampton. You'd pick up the bits you need, you'd take them home, you'd solder it all together, then you'd try it out, then you'd remove the blobs, and then you'd try again. And then without really understanding anything about how any of it worked, I just loved making these things. So yeah, that was one of my first projects, and it was quite a nice, simple thing.
Were there kits available at that time? I mean, when I was a kid, we had like
Heathkit was around.
Heathkit we had.
Yeah, I think Heathkit, yeah, and I think there were some other kits, but I was basically in pocket money territory here, so I was kind of avoiding the kits, and just because they're generally too expensive, so it's kind of just following the designs in Practical Wireless, and going off and buying the necessary bits. So you know, I always had electronics as a hobby, but then, like so many of my cohort, I ended up drifting into software as a career, and then keeping electronics as a hobby in the background. And then after many years in software, I came back to it full time, writing about it when I discovered the Arduino, and just thought I'll document what I'm learning as I do it, which is a good way to write a book, incidentally. If you do it as you're learning it, you haven't got all this sort of knowledge of people there that then kind of corrupt the message, so people don't understand. You know, they think you're trying to be clever, or they don't follow what you're saying. So writing at the same time as you're learning is actually not a bad idea. You have to go back at the end and correct all the nonsense you put in at the beginning before you knew anything about it, but it's still a good way of making sure everything gets included. So that's really where I started.
What was that first book?
The first book was 30 Arduino projects for the evil genius, with Tab Books. So there's a second edition of that now, which I did probably 3 or 4 years ago, I'd say. But the timing was great on that, because Arduino was just starting to be popular. So really, it was on the success of that book that kind of allowed me to make the jump into writing, which is what I do most of the time now. Although, as you mentioned before with Monk Makes, I'm also spending some time designing products for a business I've set up with my wife, essentially selling kits and other things to go with that accompany the books.
And we'll get into that in more depth in a minute.
Okay.
Okay, that was your first, looking at Arduino, I'm the kind of person who normally would be interested in this stuff because this is what when I was a kid, I did a lot of different projects and things, but I do not own either one. So I didn't know the difference between Arduino and Raspberry Pi. I've seen both names. The definition I came up with said that Arduino is a controller board and that the Raspberry Pi are more general computers. But if you'd like to expand that definition or talk about it a little bit, I think it'd be interesting to people who don't know.
Yeah, certainly. Well, you're right. The Arduino is a microcontroller board, which means it's an incredibly simple device. You're talking about a processor speed of 16 megahertz. And in terms of the level of technology, you're kind of looking back to the 1980s, really, in terms of performance. But it's not intended for that purpose. It's intended for controlling electronics. So people attach relays to them to turn things on and off, or they attach sensors to them to take readings. And I think one of the secrets of the Arduino's success is that it is very easy to get started with. There's not much power, but that's kind of one of the things that makes it simple. So if you're just an artist, say, who's got an installation and they want to play play a sound, or they want to turn something off, control it, or they want to control a whole load of smart addressable pixels and make a great big light display, then the Arduino is a great way of doing that. And it's cross-platform. The integrated development environment that you use to program it is cross-platform. So if you've got a Mac or a Linux, you're not excluded because you're not using Windows. So I think those are... And also, when people used to have to use microcontrollers like the PIC microcontrollers, you generally have to have specific programming hardware to use them. Whereas one of the benefits of the Arduino is that the programming hardware is built in. So you just plug it in and it's got a USB interface. You just write your code on your laptop or your computer and you upload it onto the Arduino and away it goes. It's in flash memory. It's only got 16K of flash memory, but it'll run that program as soon as it reboots. As soon as you power it up, it's running, it's working. Whereas a Raspberry Pi is a fully fledged single board computer running Linux with, in the case of Raspberry Pi 3, with built-in Wi-Fi, 4 cores, each running at, I think, 2 megahertz or a bit less. And it's it for the same kind of things as you could an Arduino if you really want to, because it has GPIO pins that you can connect electronics to. So you can do the same kind of stuff, but you've got to wait for a minute while it boots up, or you've got to set the thing up to run headless so that you haven't always got a keyboard, monitor, and mouse on it. So it's kind of horses for courses. If you want to just control some simple electronics or take some sensor readings, then you use an Arduino. The moment you need something like a big monitor attached to it, or you want to do a lot of stuff over the internet, or you want to run any kind of advanced software that uses a lot of processor and memory, like optical character recognition or computer vision, then you need a Raspberry Pi. You go straight to that kind of technology. And you can set the Raspberry Pi up for all sorts of dedicated purposes. So you can make it into a media center, or you can, people use it as like a home automation hub. So you have a load of things talking to it over to provide your home automation setup. So Raspberry Pi, single board computer, Arduino, and the various variants of the Arduino, and official boards and unofficial boards and things that are Arduino compatible. In other words, they use the same software. These are for controlling things. These are for simple microcontroller projects, and that's reflected in the price. So Raspberry Pi, you're looking at sort of $40, 30 quid. If you're looking at an Arduino, I think they're about £18, sort of $25, something like that. So the Arduino is cheaper. And if you go to Arduino compatibles, especially things like the clones that you can get on eBay from China, which is a little bit naughty because they're kind of just copying the technology. And then these things can be a couple of pounds. They can be extremely cheap. And there's the very interesting variants on the Arduino that include built-in Wi-Fi and things that, again, like the Node MCU boards, which are Arduino compatible. You program in the same way, but these things are sort of $3 or $4, which is incredibly good value.
So the Arduino can be seen in a sense as a black box, where you've got inputs, you've got outputs, and then you do I don't know what language. In the old days, this would have been like an assembly language where you look at an input and so on. You poll something. I mean, how does that work? Just,
Yeah,
basically.
Well, yeah, you're right. Basically, the inputs will be things you take from sensors, and those sensors might just be a push button or a pot with a knob that you turn. It does some processing, and then you've got outputs, and those outputs will either be digital outputs turning something on off, or there'll be analog outputs which actually control power to something like a motor or an LED or a pair of motors and a robot, that kind of thing. So yeah, it's the same basic model of inputs, outputs, inputs processing and output, but the inputs are sensors and the outputs are actuators of some kind, so motors or lights and things like that.
And there's a large market for aftermarket, I guess, or whatever, parallel market for all the Arduino stuff, I suppose.
Yeah, there is. There's the biggest part of the market actually is probably Arduino compatible boards, different types of Arduinos that you can get ones that are basically the size of a postage stamp that plug directly into your USB port. You can get quite large ones that have a large number of GPIO pins. So if you've got a fairly complicated setup that you want to, you got a lot of things to control, and you can have a load of GPIO pins if you get yourself an Arduino Mega or an Arduino Due, one of the new models. But the real benefit of these things is they're all programmed in the same way. You use the same integrated development environment to program them. And really, Arduino has almost just become a shorthand for this integrated development environment, really. And you can program the BBC microbit, which is a board I might talk about a bit later, and all sorts of other boards using the Arduino IDE, because the Arduino IDE is very modular. You can just boards and away you go. So it's quite a very flexible technology.
Okay, I'm just getting ready to show. I figured I could try to show this, and this being something I'm trying to look for a way to switch it. Okay, here we go. Let's share this screen.
Okay.
In this way, application window, and here we are, Chrome. Okay, so here we're looking at monkmakes.com, hopefully.
Yeah.
Everybody see that? Okay. So the question was going to be, what kind of things are you developing that people can be interested in checking out?
Okay.
Stuff here? Yeah.
Yeah. Well, we manufacture. We don't sell ourselves other than through Amazon.com and Amazon.co.uk, which we sort of consider to be resellers. So that we send them off a big box full of distribute them. So that's the first thing to say, really. We're a design and manufacturing company, although a lot of the manufacture is actually outsourced, or parts of the manufacturing is outsourced. So the sorts of products that we develop, initially the idea was to supply kits that accompany. So one of the questions I always get when I write a book is I get people saying, "That's great, I like this project, where do I buy all the bits?" Mm-hmm. And so we started putting together a few kits, and I think one of the first of those was for the Raspberry Pi. So it's just a little starter kit for people to do. It includes cards for 10 different projects, and it shows you, so you can connect it together with solderless breadboard, plugging the components into the breadboard, and then plugging leads that connect the breadboard to your Raspberry Pi, and then you can run some simple projects. So most of that's to do with turning LEDs on and off, and using and light sensors, and just showing how you can do various things. And then all the code is provided for that in the form of Python programs that you run on your Raspberry Pi that then interact with the hardware. So we have
this is what we're looking at. This is what I'm showing right now, right?
Is another Raspberry Pi kit we have, which is which is
sorry,
that's okay, which is called our Clever Card Kit. So this is where we've kind of gone a bit more advanced. So that's got an RFID card reader and a bunch of cards, and then we've got a couple of extras like a push button and an RGB LED that you can plug into the Raspberry Pi GPIO pins, and then build there's 6 or 7 projects included in the kit in a little booklet that you can build, and then also you can make your own projects in a simple to use library for interfacing with RFID, so that people can get going making their own projects, which is really the intention, that it kind of gets people started with it. also have some to support my book Hacking Electronics. We have a kit, not surprisingly, called the Hacking Electronics Kit, which includes just a few things to get you started with electronics, a few essentials. So there's a budget multimeter in there, and a load of the components. Yeah, thank you. And a little, a motor, a few LEDs, and a set of components really to get you started that keys in with the Hacking Electronics book, so that you can get the book and get the kit and immediately start doing some of the experiments and mini projects that are in the Hacking Electronics book. But most recently, and the products that have been keeping us incredibly busy for Christmas are for the BBC Microbit, because this is kind of flavor of the month at the moment in the education market. So a lot of people are buying microbits, or schools have been given microbits, or because the microbit, which is another microcontroller board, a bit like the Arduino, but it's designed specifically for education. And child in the UK in a certain school year, I forget which school year now, was given one of these microbits as part of the launch. So they built a million of these and then gave them away. And this has really sort of bootstrapped the whole microbit use in the classroom. So we produced a few add-on boards for that. So we have a sensor board that has a microphone, a little temperature sensor, and a light sensor built onto it. And then we have a speaker board, which is a small amplified speaker that again, and you connect things to the microbit using alligator clips, because they sort of fall off and they're a bit of a pain, but they're sort of a very easy technology, a very easy way of connecting things up to get started with, I think. So we have individual boards that we sell, and we also have a microbit kit that we sell that includes a project booklet, a 30-page booklet, which shows you how to get started connecting electronics to your microbit, to build the I can't remember how many projects you have in there, 7 or 8, I think, different projects that will get you started connecting electronics to your microbit.
I think it's really fantastic. There's one curious thing there. There's actually a little socket with what looks like an incandescent light bulb. That brings me back like 56 years to my own experiments. I can't believe they still make those.
Yeah, you can still get them, and it's they're sort of fun now in a retro sort of way. Is the sort of appeal of them. And we have a motor, because we have one of the boards that we provide is a relay board. It's a solid state relay, and so only usable for low voltage DC applications. And I wanted a couple of actuator type things that could illustrate the use of this relay. And once you've thought of motor, then after that, what do you do? Well, the only thing I could really think of was a light bulb and a light bulb holder. And it's quite nice, because you see the filament and you see how it works. So even though it doesn't put out much more light than a tiny little LED, it illustrates the principle of switching something with a relay quite nicely. Because it's a solid state relay, you can actually use PWM on it at pulse width modulation on it at fairly low frequencies, so you can control the brightness of the light bulb, which is something you wouldn't really want to do with an electromechanical relay.
That really looks like fun. It's fantastic. The tendency towards teaching everybody coding now, it's become the big thing.
Yeah.
And it is, forgetting for a moment the idea that it's the only way you're going to get a job in the future, because I don't believe that for a second, but it's fantastic for patterns of logic and intellectual curiosity. And I think that it's probably, having been there myself, gone through this path, all of us have, everyone on this call, and probably many of the people watching, have gone through this path of building stuff and looking, and you start by copying. You find a magazine, and someone's got the code, and so you load the code. Then you start trying. That's how you understand how the code is, and then you learn how to code. And so kits like this, I think, are just wonderful for kids, even if in the end they're going to do something completely different. It's just a fantastic exercise in learning, and learning how to learn is probably the best lesson there is.
Yeah, I mean, we supply all the code for all the projects, and you think, well, that might mean people just jump to the end and don't really learn anything. And there will be some kids who not necessarily interested in the coding, just want to make the project, so they can just make the project. But an awful lot of the kids will be curious about how it works. They will want to figure out what's going on with it, and as you say, they will go and look at the code and they might edit it and tweak it. So even if they just got an LED blinking, if there's a suggestion at the end of the project that says, now try and make it blink a bit faster, they can look at the code and they see delay 1000 milliseconds, and they think, oh, okay, I guess that if I decrease that, I'm going to get a faster blinking LED. And yeah, it's a skill that I think many kids as possible, or all kids should have the opportunity to learn how to code. I think it's a skill that everybody needs, is always going to need more and more in the future.
Yeah, it's absolutely fantastic thing. Very positive. We're going to open questions. I don't see any questions on IRC or on Mastodon. By the way, folks, if you're listening to this, you should go to masto.vuc.me. Join the Mastodon, because those things are permanent, unlike IRC. So if you make some posts, or you want to put links or contribute images, maybe even the projects you've done with Simon Monk's kits, that would be fantastic. But meanwhile, masto, as in Mastodon.vuc.me. I'm sure Mr. James Bodie is burning with desire to expose.
I'm burning.
As long as it involves Simon, James, and not just you.
Yes, Simon. Like you, I am surrounded by lots of little boxes and little things. But I have to say that these days there's this huge explosion with all these little boxes that are coming out of the People's Republic of China. And here's an example of one that I bought the other day for, I think, about 10 quid. So it's got an embedded Linux processor. It's got two Ethernet sockets. It's got BGN Wi-Fi in it as well, and it's £10, and you can reflash it. Amazing building block.
Yeah, absolutely.
And it just blows me away, some of the things that you can do with these really cheap things. And in the warm-up, you mentioned the fact that you've been playing a bit with the Sonoff devices, and that's another complete family. What have you been doing with Sonoff?
At the moment, I've just been buying them. I haven't actually got around to connecting them up to anything yet. So, but yeah, the Sonoff range of devices is very, very good. It's you can get just a simple inline Wi-Fi relay, effectively. So you can wire that up to you've got an AC outlet extension lead. You can just splice it in line in that, and then you've got a way of you can set it up to work with things like the Google Home Mini, which is why I've got hold of this thing. So I've got hold of a that's the one that you spice.
This is the basic one. They're about £5.
Yep, something like that. And then they also have a light switch, which is very nice. Actually quite a stylish looking light switch as well. So I've ordered a few of them to come. And the idea is I'm going to hook all of these things up with my Google Home. Bought a few of those at Christmas while they were down to 35 quid each. I thought, right, that's just too good a thing to miss.
Well, again, these components are so cheap now, but so powerful. Just looking at this little relay box, it's got this embedded system on a chip, an ESP8266, which is some kind of very capable multi-core processor with Wi-Fi on board.
Yeah, it's it's Nordic Semiconductor produced the chip, and it's the whole thing is very powerful. And this is one of the boards that actually you can, other than I don't think this board has a serial or a USB. I think it has a serial. Connector. But
if you go over here, you can actually jack in here and get into the GPIOs.
Yeah, that's for GPIOs, and I don't think it has a serial connector. But
you don't need it because you've got the Wi-Fi, and so you can talk to it over Wi-Fi.
If you have the ESP 8266 is available in formats on eBay from anything between sort of £2 and £6, and those boards, there's one of those is called the Node MCU, which has a USB interface, which I've started using for a few energy monitoring projects that I've got around the home, and those you can program as an Arduino. So you have to install something into the Arduino development environment, and then you have a little Wi-Fi board with a load of GPIOs on it that you can then connect up to your electronics you need or whatever sensors you need and use like an Arduino.
Yes.
So,
and of course, another comment is another building block that we have now are these cheapest chips Android handsets. And so for £50, you get something with a battery, display, Wi-Fi, Bluetooth, GPS.
Yeah.
You can even, if you want to, you can even make a phone call with it. but you can do lots of other amazing things with it.
Yeah, I mean,
if I can go
essentially, a Raspberry Pi is almost the hardware part of a phone, but without without the touchscreen on it. Really, I mean, you're using the chips that the chip used on the Raspberry Pi is the same you would find in a reasonably good mobile phone. Yeah. Right. So, but if you buy a mobile phone, you got all the peripherals already, haven't you? You don't have to worry about attaching a touchscreen to it. So, if the application you need involves a touchscreen, you're probably better off just learning how to do some Android. Which, well, last time I did some Android programming, it was a little tricky. But I'm guessing that there's technologies that make it much easier to build yourself an Android app these days that will do things. And also, with an Android phone, you don't have direct access to any GPIO pins to hang any electronics
off.
No,
that's true. But you do have the Wi-Fi and the Bluetooth, so you can talk to other devices. Yeah, and you've got USB out of the back end of it. So
yeah, absolutely. Yeah, I did.
Sorry.
I was just going to say, I did do a book a little while ago. It's somewhat out of date now, so I wouldn't recommend anybody buy it. But it was Android and Arduino projects. So the idea was that you could, Google had a standard that allowed you, I can't remember what it's, open accessory standard that allowed you to connect your Android phone to an Arduino. So that kind of gives you GPIO pins on your Android phone.
Okay, here's another little project that I did. I was doing with the kids. This is a little Dvb TV receiver.
Okay, nice.
And they cost about £9. But you can use it to do basic software-defined radio applications.
Wow.
And so what we did was we were taking kids and giving them one of these and getting them to use their own smartphone as the terminal to run an application. And they were then receiving the ADR transmissions from aircraft at around 1,000 megahertz. And then, so you could then plot the location, speed, height, of the aircraft, but receiving the radio transmissions directly on one of these.
Wow,
it's kind of like the 21st century version of the Crystal set. And the great thing is that you can take a relatively competent 11-year-old and you can get them to a state where they can actually receive all kinds of stuff in about 20 to 30 minutes, and it blows their minds. They really love it.
One thing, have you come across the Pi FM project?
No, I haven't. What's that?
Well, it's wonderful as a demonstration because it's a software FM transmitter.
Right.
It's a DMA channel on a Raspberry Pi. So you don't need any hardware at all, apart from your Raspberry Pi and a short jumper wire to connect to GPIO pin 4 of your Raspberry Pi. And then you run the Pi FM software, and you then run a command line, a Linux command line command called Pi FM, followed by a frequency, followed by an audio file to play, or a stream to play that comes from, say, a microphone.
So you're training the next generation of pirate radio people.
Exactly. So you just get yourself a little FM transmitter, put it in the next room or just at the end of the room, and then you have you've essentially got something that can transmit direct to that. I've no idea what the output power of that is, and the legality of actually making yourself a transmitter. But it's relatively low power, so I'm guessing it probably falls under the same kind of legislation as you would for those little things you used to get into the car so that you could listen to your MP3 player on the car radio. So I don't think so. Hopefully it's not too powerful to get you into trouble, but a lot of fun.
Well, no, that is a good example of something new. It must be a really big challenge for you, just keeping up to date with all the developments.
Well, yeah, I mean, when it comes to sort of maintaining old books, it works reasonably well because people are quite happy to tell me when I'm out of date, which is really handy. There's some of that time that doesn't work because this library is now on GitHub and not on Bitbucket or something. But also people will tell, it's good to talk to people, and people will tell you about new things coming out, and what's interesting and what's happening.
Yeah. So, Simon, that brings up a question I have for you involving the internet and as an author. When the internet first started becoming popular, I bought a book in the United States. I can't remember what it was called, but the author actually had his email address in it, which you probably do or have some kind of contact information. You're easy enough to find anyway. Point is, this was a revelation in that you could now talk back to someone and, to ask questions or say, look, I read your book and blah, blah, blah. Hopefully it's not to tell people bad things or necessarily simply to tell them good things, but to have this back and forth. So you just said that people have told you when stuff's out of date or unavailable, which is great. But what other kinds of, how much of that do you get? How much input do you get from these books? Because you've got something like 26 books now. You must have 1 or 2 emails each day about it.
I get quite a lot of emails about them, actually. It's actually multiple channels that you could spend a lot of time monitoring all of these channels to make sure you catch everything that happens. And I don't catch everything that happens, unfortunately, but I do my best. So one of the most common, one of the things I do monitor is the Amazon reviews. So if it's just praise or whatever, that's absolutely fine. If it's I've given you 1 star because it took 2 days to arrive and I wanted it in 1 day. That's like, why is that my fault? But you can't do anything about these things. It's just how it is. And it averages out when you get enough reviews on there. It doesn't really matter. But you do quite often find people pointing out useful things in those reviews. And it's an open forum. So other people will sometimes help you out and answer the question for you. But I always keep an eye on it anyway. So if there is something people have misunderstood or they can't find the source code to download, it's because they've missed it. It was on page 23, but I probably should mention it more. Note for the next edition, mention each time with the code where you download the code from, so people, because it's easy to miss things, if it's just in one place at the beginning of the book, you skip past that because it was the introductory chapter and you didn't find it. So so there's the Amazon reviews. I do get people responding emails. I came in on the 4th edition of Practical Electronics for Inventors, which is like an 1,100-page tome on electronics, originally written by Paul Schertz, who's an American physicist who I think he works in another field now, but originally is a physicist and has a incredibly detailed and encyclopedic knowledge of all electronics theory, despite the title of the book. And I still get a lot of feedback on that book where people have either want something explaining that I can't always do because this is stuff that Paul did a long time ago and I don't know. My theory isn't that good. So it's there's various different channels that I have to keep an eye on and make sure that I keep it. And it's useful because it helps improve the books. And the way that publishers work these days is that, yes, for anything that major changes, you have to wait for a second edition. So if you're adding new pages or a new chapter or something that completely upsets the layout, then you have to wait till the next edition that might be every 3 years or every 4 years or something. But if it's just a minor change, they sneak them in every time there's a new reprinting of the book, which is great. So the book does gradually, the number of defects in the book gradually decreases and so the maintenance load for that particular book decreases as people find the bugs in them. I do generally have technical reviewers on my books now, but it doesn't matter. You can have as many people as you like read it as many times as you like. Things will always sneak through. There will always be typos or slight technical in your work.
Right. I wonder if there is not an interest in direct publishing on Amazon, because I only bring that up because in that case you can actually make any modifications you want anytime and continue to grow the book. Have you ever done that on any Amazon or other platforms, or not?
Yeah, I did. I have experimented with doing a self-publishing. I did actually one with my son on Minecraft. Well, actually, a particular mod to Minecraft called Computercraft that he was very into at the time, and we had a lot of fun doing that as a sort of summer project one summer while he was off from school. I think publishers still have their place though, because it is actually quite. They do something behind the scenes. They take most of the money, but then they do quite a lot of work. So they have a marketing department. They have people who go out to book fairs and sell the international rights. They have people, they have proofreaders who go through everything you've done and try and at least correct the worst parts of your English. And then they have somebody who will do a great job of layout, because I've tried doing layout and I can't do layout. I can do layout, but it looks rubbish. So, or certainly not comparable to what you get if you have a professional doing it. Somebody who just does layout every day. They're much better at that. They do it quickly and they do it well. And also, if you're working with the layout of the book, it's easily get seduced into the look of the book and say, that looks nice because it's got a... I prefer to work without the layout. I prefer to work with copy for the text, just in a Word document, no pictures whatsoever, separate image files. And you get used, and it kind of introduces a discipline. I suppose it's a bit like some writers who still actually like to use a manual typewriter, because it kind of it separates the whole content from the appearance, so that you can concentrate on getting words right and including everything you need to explain what's going on without getting seduced by the appearance of the thing. Because just because it looks like a book doesn't mean it makes sense.
No, that's totally a distraction. I totally get that and understand it. Curious, one of the other things that publishers can do that would be expensive and time-consuming to do would be translations. Are your books translated, Simon?
Yeah, most of them, all the successful ones, all the ones that sell, get the international rights get picked up, and again, generally, the publisher doesn't get involved in the translation. It'll be a local publisher in a different country who does the translation. So yeah, a lot of my books are available in Chinese, Russian, Polish, Spanish, Portuguese, quite popular. I think largely for the Brazilian market. There is quite a big maker community in Brazil. They do, my books sell quite well over there. So you do. That's another thing. You're right that I'm not going to go along to the Berlin Book Fair and talk to people and say, do you want rights to my book? So yeah, they still have their place, publishers, and they do act as a filter in kinds of. Because they provide somebody who's going to do a technical review of it. And some of my publishers let me choose the technical reviewer, but it's probably better that I don't. And if they find somebody who's completely independent, who'll read over it and just flag anything up that they think's not right or shouldn't be there or needs more explanation, then that's really helpful.
What directions are you seeing this going in? I mean, surely there's going to be some new, I don't know, AI, VR, to name a few flavors of the month. Where is this whole thing going? We can't just keep having the black box, the Arduino that controls the input and the output. There must be some progression here. So what is your next, what is your view on that?
Okay. Well, one of the things I put in the Raspberry Pi cookbook, the second edition that I finished probably a year ago or so now, I think maybe it's been out about that, was to put in a chapter on computer vision. you can make your little roving robot with an Arduino, and you can just drive it forwards, backwards, left and right and things, and you can have an ultrasonic rangefinder on it that tells it when it's about to crash into something and make it stop. But what's really nice is you can stick a camera on the front of your little roving robot and have it follow you or identify faces. Or you're going to do that on an Arduino. You need some serious processing power and some serious memory. And a Raspberry Pi 3, absolutely fantastic for that. Plenty of oomph. So I added a chapter in there on computer vision. But I've recently started. Well, I bought myself a book on machine learning. So my sort of hobby project at the moment has been, I've just started really working through this book using the machine learning Python, which it seems astonishing that you would do machine learning in Python, but really the Python is kind of an integration technology to lower level libraries that are implemented in something more efficient like C. And all of the tools for doing machine learning are just made publicly available. I mean, Google has released, I think the tool I'm using, I can't remember what it's called now, but I only just got into it, is a Google-based tool for machine learning, and you can plug in. It's very modular, so you can sort of say, right, for this, I'm going to train it. You put aside some of your data for training and your data for testing, and you keep these things separate, and you train your thing on it, and you can choose the model you want to train. You can say, I want it to be a multi-layer perceptron neural network, or I want it to be a linear regression model. And it's done at a really high level of abstraction. You don't have to get into really nasty low-level detail. I think it's very easy to fool yourself that you've trained something and it's working well and it's not. I think there's lots of sort of things to do with data analysis that you have to learn, and you only learn from experience. But the actual coding side of things is really straightforward. So machine learning, it's impacting on every area of our life already. I mean, my Google Home Mini just said something to me. I don't know if I said "Okay Google" or something accidentally in there, but it's I think the voice interface is a very natural one, and it's just getting better and better. And I can see it as being really useful things like assistive technology. I'm training myself to get used to it so that when I'm really old, I can just bark commands to it, have it do stuff for me.
Interestingly, and I posted this in IRC a few minutes ago, just as it happens, someone from Raspberry Pi posted that the new post, Raspberry Pi hardware is unaffected by the Meltdown and Specter vulnerabilities.
Oh, okay.
And he provides a crash course in modern processor design to explain why. And Dan Jenkins is with us in IRC, and he thought it was well, if it's powered by ARM, isn't it? There is a link. I can't read it, but you'll have to go on Twitter or probably just do a Google of it, Specter or Meltdown Raspberry Pi, and you'll find it. But I haven't read it either, but apparently they are not vulnerable. Everything else we're talking on right now is, but yeah. I'm not that worried yet. Anyway.
Yeah. No, it's interesting, because the electronic engineers who came up with this, with the idea, I think it's to do with predictive instruction execution, isn't it? So kind of the processor kind of guesses what you're going to do next when it gets to a branch, and it goes off and does it. And this kind of provides a backdoor in so that you can go and look at bits of protected memory that you shouldn't be able to look at. So you can basically see all the RAM on your processor, or in your processor cache. I don't know. Anyway, it's a vulnerability that is worrying, because it does essentially mean that anybody can just see, any program can see everything that's going on in the RAM.
Right. Well, I can see. Apparently, you're completely up to date on that. It's interesting. Yeah. No, that is the exact explanation that I've heard.
Right.
It's scary in that it's something that maybe people who are involved in the engineering of these chips knew that and said, someday they're going to do this because that's what we do. But for the average person, even people like us who are interested in this stuff, I never imagined that to be possible.
No, you wouldn't.
Nor did I foresee when Snowden was talking about how people can listen to your phone when it's apparently off. And I thought,
right.
How could that? And apparently, I mean, there are so many things that we don't even think of ever.
Yeah, and
there's just so much insecurity.
There are embedded processors anyway. I was just going to mention
in everything.
There's an embedded processor with memory in this thing. And in fact, this particular one has more processor power and more memory than the first generation Pentium PC. And that
brilliant.
And people don't realize that. They think it's just a thing you slot in.
Yeah. How much memory is in there?
This particular one is about 340 meg, I think.
Wow. Yeah. Well, I had 16K on my first computer.
Well, there we are. As much as that.
Yeah. Well, I got the expansion box, and then I got the other 32. By the way, I just saw something flash by a couple of days ago that there are now credit cards that have fingerprint readers.
Yep.
Oh, really? You heard about that?
No, that's a nice idea.
It's crazy.
Where
but
do
then
they get that power from?
Well, but where's the exploit? I mean, imagine the exploit on that. I don't know. There's just somebody will come up with then a card that you somehow switch with somebody. They use it once, then you switch it back, and you have their fingerprint for all kinds of illegal and illicit purposes. So I don't know. We are going into an era of incredible complexity, and
well, in fact, I was thinking about this, Randy. When we started off, you and I started off, we were playing with thermionic valves, and that sort of thing. And look where we've come to, where we've got huge amounts of power in kind of everything, and it costs next to nothing.
But it doesn't heat the room, James. I'm freezing in there, which is why I have this wonderful leather jacket from Suzanne Bowen.
Yeah, your Tintin jacket.
The Tintin jacket. Dan Jenkins mentioned, Simon, that you keep keying his Google.
Okay, Google. Self-destruct.
Okay, Google.
Okay, Google.
Turn the
play
lights
loud music.
Let's do another call to things related to Simon himself and see if anybody's got any comments or questions. I'm looking at Mastodon. I'm looking at IRC. We are listening on ZipDX. If anybody's on ZipDX, you hit *6 and you will be unmuted and be able to blurt out all kinds of things that you may want to know.
So I have a question for Simon, and it is have you ever heard of a magazine? This goes back to when I was a kid. It's a magazine called Electronics Today.
Oh, yes. Well, is that the one that became Electronics Today International?
Yes, because I was in Canada and I loved that as a kid. They had fascinating projects, and I was seeking to find like an archive of it, and it so far predates the internet that it largely doesn't exist as far as I can tell.
It's probably the sort of thing you might be able to find on eBay, where you could buy a bundle of them, but if you're lucky.
Yeah, because they were, I don't know whether they were out of the UK or out of Australia, but we got them in Canada, and they had some local writers in Canada. And they had, I remember on their April issue when I was in high school was how to make a microwave emitter that was the size of, basically you started with a big steel wheel from a tire, and you wound about 300 million wraps of magnet wire around it. and basically it was designed to fry police radar guns.
Oh, nice. That's proper hacking, isn't it? That's old school hacking, that is.
Is that, if I remember correctly, April '73, something like that, they ran a spoof of a new nuclear power chip.
Yeah.
That came in like a 28-pin dill package or something.
Okay.
It was absolutely superb stuff.
Yeah.
It was really splendid.
Yeah.
Sorry.
Yeah. Well, I mean, this metal detector I made from Practical Wireless, or I mean, it was huge, and it would just about detect a car if it was about half an inch under the ground. That's about it. Not terribly sensitive, but the fun involved in making it is what it was all about, really.
I think probably all of us have made. I know I made a metal detector. Probably made it out of a kit that I purchased. But I mean, that's one of the things. Pretty geeky stuff, Simon. Actually, but that is the kind of thing we did. I have a question from Kathleen King from the Free Switch world. who asks which kit would be your personal favorite for beginners and why. I think I know the answer, but I'm going to let you say it anyway.
Okay. It depends. Oh, actually, it depends what technology you want to learn. I think if you want to learn Arduino, then we do have a kit that hits that. That actually, we have our own Arduino clone, which we call the Monk Makes Duino, which is designed for breadboard. So it's a single inline design. It just fits down one side of the solderless breadboard, leaving you the rest of the breadboard to do stuff with. So we do have a kit for that if you're interested in Arduino. But also the ARDX kit, which isn't anything to do with us, is a very good kit to get you started with Arduino. It includes project cards and a whole load of basic components to get you going. And it also is a breadboard-based kit. If you're interested in Raspberry Pi, then that too. Well, in fact, we have quite a few kits for the Raspberry Pi, but our electronic starter kit for Raspberry Pi is still just about our best seller. We're starting to sell a lot of microbit stuff now, which is kind of overtaking it a bit. But the electronic starter kit for Raspberry Pi that we produce is quite a good one to get you started. There's also kits from CamJam, which is it's from the Cambridge Raspberry Jam community, and that does some of the same things as our kit. I don't think it has quite the range of sensors and things. It's kind of a little bit more basic, but it's also cheaper. So it's really good value, the CamJam kits. So yeah, there are plenty of kits out there. I think you'd struggle to find a really bad one, to be honest. And a lot of it is about the documentation. I think that's the thing to check when you're thinking of buying a kit, and make sure it's got some good documentation that explains how to build the projects and how to get started.
I think another little tip, an annex to that, Simon, would be to do some searching. We all know how to use Google now, because there are so many forums. And if you find the forum and you see, I mean, I've done this, believe it or not, low tech. I've done this with electric radiators, where I had to find some information, and I found a place where people hang out. And I mean, these folks in this country too, where these folks know everything you could ever imagine has ever been known about electric radiators, every technology. So, you know, if I went in there and asked a question, I said, how do I do this? I mean, within a day, I had several extensive answers, and not people who are going, and if you want more, call me because I'm a plumber or what, you know, these are just people who know what they're talking about. And so on any of these devices, especially knockoff stuff, I would look it up first on the internet and see if you can find people talking about them on forums. I did this with my little TV. I have an Android TV, for example.
Right.
I looked at different brands. There's a whole bunch of them out there. And there are lots of different technologies out there. And if you look, you do a Google and you look at what people are saying, you may run into, for example, something saying, hey, this is a dead end, forget it, I'm really disappointed. Or you may find a whole bunch of people talking about, yeah, I did this and I did that, and here's the code. You can go download this plugin. I mean, so this is fantastic. And that's why the internet is a great thing for those of us who want to play around with these things. That's also why monkmakes.com is the place to go take a look at how was that for a segue for all of these boards. But again, you can look up and see what people are doing with this stuff. These kits are excellent.
Absolutely.
Especially for gifts.
Yeah, no, it's good for gifts. But going back to your thing with asking the community about things, that is an incredible value comes from the internet, because you look at some of the kits that you might see offered on eBay that include a huge array of sensors and resistors and things, and a clone Arduino, and zero instructions on how to put any of this together. Some of that you can find from the community quite often, but other times, if you look at the reviews, you'll say, I bought this kit, it's wonderful, I've got lots of different components, I don't know how to use any of them. So it is worth looking at reviews and seeing what people say about products before you buy.
Excellent. Any final comments before we let Simon go? Not that we're really going to let him go, but
I have one. Do you actually ever solder anything these days?
Good one.
You know, we've got these new microbit products, and we're getting them made in quantity in China where somebody else is doing the soldering. But I spent over the Christmas period, because we've had orders that we've been trying to fulfill, I spent days soldering over Christmas. Most of it surface mount. So I've been impersonating a pick and place machine. The solder paste onto a board, and then dob components like this, another one on the tray, down to the reflow oven. So yeah, I still do soldering, and I really enjoy making a project that's just for myself, that I'm not going to include in a book, and I'm not going to write up. So another thing I've done not very long ago is we've got some photovoltaics on the roof of our house, which might sound like a stupid thing to do in Lancashire, but we've done it anyway. But one of the things I wanted to make was like an energy monitor. So I've got a little a CT transformer, a current transformer, so I can sense the amounts that put in and out of the house. And so I've modified our clock in the kitchen, so it has a little row of NeoPixels around it, which shows it whether it's a good idea to put the tumble dryer on or not. So if you're green, then you've got excess power, and how many green lights you have is how much excess power you've got. If you're red, then you probably just put the kettle on, or it's a normal dull Lancashire day and you can't run anything extra. So yeah, I do still get to solder, but I do it for fun now.
And actually, the whole thing about photovoltaics and where you should use them and where you shouldn't use them is quite interesting, particularly when you look at the advances in the efficiency of the more modern ones these days. So it's certainly fine. It's in the UK or just about anywhere, really.
Yeah. I mean, one of the things I don't know actually is whether the life of the cell is actually longer if you live somewhere where they're not constantly being bombarded by large amounts of light radiation. So it may be that over the lifetime of the solar panels, you actually get more. You get the same amount out just because they last for longer. I don't know if that's true. I don't know what it is that degrades the performance of the photocells, but I like to convince myself that it's actually a good thing to do. Yeah, and it pays for itself. Linda and I both work from home all the time, so we use most of our electricity during the day. So some of the time we're running the laser cutter or running the reflow oven on solar power, which is a lovely feeling. Being very green about it.
Yeah, I was going to say it may not be the most efficient thing to do from a monetary perspective, but it is very green. So well done, sir.
Yeah, thanks.
And speaking of green, Simon, I want you to come back and talk to us before 2022, because it's 2018. Okay. You spent 4 years in your corner working on this stuff. Now let's get together a little sooner next time.
That'd be great. Good.
Okay. Simon Monk,
well,
thank you so much for joining us again. Thanks to everybody. We're going to cut off, but we're going to go into the mature audiences only version of the VUC right about now, 5